You're welcome to Dynamic Educational Hub channel. The answer to the very question. And this is a channel where I dissect various topics in physics, chemistry, and maths. If this is your first time of coming across my channel, kindly subscribe to this channel. Click on the notification icon to get notified when I release an insightful video like this. And what are we going to learn in this video? This video is a continuation of the former video, and we are going to start by solving the quiz in the former video. If you haven't watched the previous video, kindly watch the previous video in this playlist. All right, without further ado, let's start. Now we have this beautiful question here, which is: different forces act on a block on horizontal surface as shown in the diagram if the coefficient of friction between the box and the surface is 0.5. Find the magnitude and direction of the resultant force and equilibrant force. Find the acceleration of the blocks along the surface. We are given acceleration due to gravity, which is 10 meters per second square, and we have this question. Let's see how to solve it. Now, this is our diagram from the question. Let's observe it before we start solving it. Now, from a former video, I explained that when you want to solve this question and you are given coefficient of friction, so which means that in your analysis you must include frictional force. Now when you want to start solving it, you must fix the direction of your frictional force, because we have two forces acting here and one acting in opposite direction. So the frictional force, you assume either this direction or this direction. Then how can you fix your frictional force? You assume that we don't have friction here, so which means this box can easily slide on this surface with zero friction. That is what will give you the idea of the direction. Then you can now find your resultant. Now finding the resultant, or you observe it, you can use it to find the direction of your friction. What did I mean? Now we have 1200 Newton acting towards this direction, and we have these two forces acting towards this direction. So you can find the total sum of these two forces, which is 500 Newton plus 300 Newton. Now we have 800 Newton versus 1200 Newton. It means that this 1200 Newton is greater than this 800 Newton. So this box will slide along this direction. It's going to slide along this direction. As it tries to slide along this direction, now insert your friction. Frictional force will act in opposite direction. So our frictional force, we assume this direction. So let's start. Solution. The first thing, we are given the coefficient of friction. We have solved this in our former video, so I'll be very fast. Coefficient of friction is 0.5. So we given acceleration due to gravity as 10 meters per second square. Then the reaction is equals to what? Your normal reaction, the mass of this object multiplied by acceleration due to gravity, which is 40 multiplied by 10, and that is 400 Newton. So what do we want to use this reaction for? We want to use it to find the frictional force, limiting frictional force, the static friction. Now this is the direction of the friction as explained earlier on, as shown. Now let's find that friction. Frictional force will be coefficient of friction multiplied by your normal reaction. This is our normal reaction here. Coefficient of friction is 0.5 multiplied by 400, and that is 200 Newton. So we can fix the coefficient of friction now. Let's put the force, which is 200 Newton. Now we have 3 against 1. So we have 3 forces here. We have 3 forces here. We have 500, 300, and 200 against 1200. So let's find the resultant. Now the resultant is going to be 1200 minus the total sum of these 3 forces acting in opposite direction. Look at your diagram, opposite direction, then you subtract. So we have 1200 minus 500 plus 300 plus 200. So that gives us 1200 minus 800, and that is going to be 400 Newton. And that is going to be 400 Newton. Now let's fix the direction. Since this object will slide along this direction, according to our analysis, the resultant force is not equals to 0. So this object is going to slide towards this direction. That is why we have a rightward, and also known as what? East. So this object slide along this direction. That is the direction of the resultant force. Now that we have the resultant force, which is 400 Newton acting along this direction, so let's fix the equilibrant. So equilibrant is going to balance this force, and our equilibrant will act in opposite direction, which is also 400 Newton, but acting towards the opposite direction. So if you now apply 400 Newton to our force system along this direction, it means that this object is not going to slide, it's going to stay at one position. So this is the direction of our equilibrant as shown. Now the final question asks us to find the acceleration of this box. So to understand how to find this acceleration, let me show you this. Now this force will drag this object along this direction as shown, and that object is moving by this force 400 Newton. We push this object along this direction as shown. Now acceleration is the change of speed, isn't it? When the speed increase, when we have a positive change in the speed or in the velocity, there we have our acceleration. Now this object is having a mass, and don't forget force. What is force? Mass times acceleration. That is what we are going to use. Now force is equal to mass times acceleration, and which force is causing acceleration here? 400 Newton. So we can make our acceleration subject to the formula. Acceleration will be what? Force divided by mass, which is also F over m. And which force is acting here? 400 Newton is pushing this object, despite the fact that we have multiple forces operating on that system. The one that is moving this object is actually 400 Newton, the one that is pushing this object forward from our analysis. So that means that this force will be equivalent to this mass multiplied by the acceleration of that mass. So solving it, acceleration force over mass 418 over 40, which is 10 meter per second square. This question is simple. All right, that is how to solve this question. Let's move to the next thing. Let's quickly learn how to resolve force and what led to resolution of force. Remember, force is a vector quantity, so which means when you're applying a force, there will be a direction of the force application. So let's have two axes, y-axis and x-axis, and let's have our object. Now look at this object. This object is at equilibrium. It's not moving, it is stationary. So equilibrium, the total force acting on this object is 0. The resultant force is 0. And let's assume we have a force that is applied on this object as shown. Look at the direction of that force, upward. Now that force is only acting towards the y-axis, so we have Fy. So this force is going to drag this object along this axis. So our object has been displaced. Don't forget, force is an action that causes displacement of an object. So we have this being displaced. What happened? This object still maintains its x coordinate, so it only changes along y-axis. So that is why we now have final vertical position or coordinate. So here will be y0 and here will be y1 or y. So that is the final coordinate. So this object only change its position along y-axis because this force is only acting along y-axis. So let's drop it back. Now we now have vertical displacement only. In the same way, let's have our object and let's fix the position of this object. So we have initial horizontal position or coordinate. So if a force is acting like, so this is the point here. If a force is acting along f-axis as shown, what will happen? The object is going to slide along this axis, which means that this object only experiences horizontal displacement. So this is the final horizontal position or coordinate, which is x0. Initial is xi. So the distance between these two, that is our horizontal displacement. So it experiences horizontal displacement only. In the same way, let's see when a force is inclined as shown. What will happen when a force is inclined as shown? Let's fix our coordinates. So this point is x, I and y, which is horizontal and initial vertical position. So we have initial horizontal and vertical position or coordinate, which is xi and yi. Now when this force is applied and this force is inclined at an angle, what will happen? This object will move along this direction So which shows that what this object experience both vertical and horizontal displacement as shown. So we have, this is the final point, final coordinates, final horizontal and vertical position or coordinate, which is x, naught, and y, naught. So it experienced horizontal displacement as shown. It's also experienced vertical displacement. So it now means that when we apply a force as shown to an object, and that force is inclined at an angle, that force is going to have two effects on this object. The first two effects is to displace it vertically, and the second one is horizontally. So the first one, horizontally, this object will try to slide along this direction with an effective force of horizontal force, horizontal component of this force acting towards this direction. In the same way, it's going to have vertical component acting towards this direction. The one that is responsible for vertical displacement is this guy, and the one that is responsible for horizontal displacement is this component. So which means that there is an angle between these two forces. Now the first one is angle between the horizontal surface and the force that is acting. So let's give it theta. And the angle between the force that is acting and vertical axis, let's call it alpha. Now what is the meaning of this? We know from trigonometry that this angle, when you add it together, you get 90 degrees. That is complementary angles. These two angles complement each other. When you add it together, you get 90 degrees. Don't forget this theta here. This theta means the angle of inclination of the force that is acting with the horizontal surface, and this alpha is angle of inclination of the force that is acting with the vertical pole or vertical axis, angle between horizontal axis and FR, and angle between vertical axis and FR. Let's see what will happen when this force acts on this object. Now before I explain it, just imagine you have an object as shown and you have two forces acting on this object. Let's say we have this vertical force acting, which means acting like this, and horizontal force acting like this. In some other way, let's say we have objects and someone is trying to pull this object upward like this, vertically upward, and that force is Fy. Another person is trying to pull this object along this direction, that is Fx. What will happen? This object will neither move upwardly like this vertically, so that object is not going to have vertical displacement alone. In the same way, that object will not slide along this direction like this, but the object will drift along this direction. So which means that the resulting effect of these two forces that is inclined at 90 degrees to each other, vertical and horizontal, will be along this direction, which happens to be our what? Our FR. So as they are pulling it, that object will move along the direction as shown. And what is the value of the force? The resulting effect, the resultant, which is Fr. So in some other way, if an object is being pulled like this, it's having two effects, which is Fy and Fx. So if you don't want to use that force, you can as well apply two different forces that will have the same resulting effect of this Fr. That is the resultant force. So let's now do trigonometry. So if you draw a triangle like this to represent this, what will happen? This is a right angle triangle, and using Euclidean geometry, we have alternate angle. This angle alpha will be this here, using alternate, since this line is parallel to this line, and we have transversal line. This is theta already, the angle between the... Now let's fix the side of this triangle. Now this is our resultant force, Fr. So we want to use vector, since force is a vector quantity, so we want to use vector to analyze this. We want to use law of vector. And this one will be our Fx, which is the horizontal component of this force, of this resulting force. And this side will be the Fy, the vertical component of this resulting force. So if you are picking theta, we know that the longest side is hypotenuse. That is why we have hypotenuse here. So if you are picking this theta, we are using this theta, angle of inclination between the horizontal plane, which is horizontal axis, and the resulting force, the force that is acting. We pick it, this one is opposite, this Fy is opposite, and this Fx is adjacent. That is why we have adjacent here and we have opposite here. So using trigonometry, we see that sine theta is equals to what? Opposite over hypotenuse. What is opposite here? Fy. And what is hypotenuse? Fr. Finally, we can cross multiply and we have Fr sine theta is equals to Fy. So which means that the vertical component is this. So the same way, cos theta is also what? Adjacent over hypotenuse, which is Fx over Fr. When we cross multiply, we get Fr cos theta is equals to Fx. So that is the horizontal component of the resulting force. There's another relationship again, which is tangent of this angle is opposite over adjacent, which is Fy over Fx. So you can find the value of this angle by finding the inverse of this guy. So looking at this diagram as well, we all know that this is a right angle triangle, and for right angle triangle there's a relationship between all the three sides from Pythagoras theorem. And even though we are using triangle to represent this force system here, according to triangular law of vector, which says when we have two adjacent sides of a triangle, when it represents two different forces acting on an object, the third side of that triangle will represent the resultant of the two forces, and we can see it here. Now, using Pythagoras theorem, we know that Fr square, which is the hypotenuse, is equal to Fx square plus Fy square. So making Fr sort of formula, we now have Fr will be square root of Fx square plus Fy square. Now we have derived an expression for this. Summary: if you have a force acting on an object like this, the first thing is we have 2 points here, 2 axes here, vertical axis and horizontal axis. We are going to have an angle here, which is angle between the horizontal and that force. We are also going to have another angle here, which is angle between the vertical and that force. And we are choosing just one for our analysis, which is angle between the horizontal and the force, which is theta. Now using it, horizontal component of this force acting will now be what? Fx, which is Fr cos theta, which means that the horizontal component of this force, Fx, so Fx will be what? Fr cos theta. And the vertical component of this force, which is Fy, Fy will be what? Fr sin theta. And there is a relationship between this angle as well. To find this angle, which is the direction, don't forget this angle is called direction. Now the direction of the resulting force, which is this theta, is equals to tan inverse of Fy, which is vertical force, vertical component of this force, divided by horizontal component. You now find the tan inverse, and which is the direction. Don't forget, this theta is angle between the horizontal and the force that is acting. So to find the resulting force, which means this force that is acting is still the same thing as what? Square root, using Pythagoras theorem, square root of the square of horizontal component force plus square of the vertical component of the force. Again, angle and this angle. And what's the relationship between these two angles? They complement each other. Theta plus alpha is equals to 90 degrees. So that is resolution of force. So let's look at concurrent force system at equilibrium. Let's observe something here. Now, condition for equilibrium. If you look at this force system, this is concurrent force. So we have concurrent forces here. Now, the condition for equilibrium means that even though when all these forces are acting on this object is not moving. It is at a stable position, is not changing position. That is what we call equilibrium. Now, what is the first condition? Resultant force must be 0. So after, all these forces, they are going to have their effect on this object. Now, when you find the cumulative effect of all these forces and you get 0, which means the resultant force, it means that this object will not move. That is the condition for equilibrium. In the same way, which means that the auxiliary sum of vertical components of the forces acting on this concurrent force system must be equal to the horizontal components. What did I mean? Each one of these forces will have two effects, both vertical and horizontal effects. Another thing we need to observe here, let's look at the direction. For F4, look at where it's pointing. So instead of having F4 here, we can have it here. So you need to consider the sign. It's acting upward. So instead of having it here, we can draw it here. If you want to find the resultant force of this concurrent force system, what you need to do is you convert them to their various horizontal components and vertical components. And to do that, from my previous explanation, you need to find angle, which is angle of inclination between the horizontal plane and your force. You can also use vertical plane, but to use vertical plane, you must understand trigonometry very well. So which means that where you are seeing sine is going to change to cos. That's just the scenario, because the angle of horizontal and vertical, they complement each other. Now to do it, for this F1, you have something like this. It's going to have two effects. Now look at the direction of F1. It's going to try, this F1 will try to move this object upward, vertically upward and rightward as shown. F2, the same thing. It will try to pull this object upward and leftward. What about F3? F3 will try to pull this object upward and leftward. What about F4? Now we will draw it here. For F4 will try to pull this object upward and rightward. What about F5? Look at the direction. So it will try to pull this object rightward and downward. Now let's analyze it. These ones, they are horizontal components, and look at it. We've converted this force system into coplanar force system. So which means that to find the resultant force along horizontal axis, so you are going to add the one that are traveling along the same direction together. You add this with this with this, and you subtract it from the addition of these two. Then you can find the vertical one as well. You add this with this with this with this, and subtract it from the one that is acting downward. Then you can have your right angle triangle, and using Pythagoras theorem to evaluate your resultant force. In doing this, you need to find your angle. Let's find our angle. We have two approaches to finding the angle. There is one that I will advise you to use if you don't understand trigonometry. So let's see. This is the first approach. The first approach is to start measuring your angle from the horizontal components until it reaches the force that is being applied. So let's see how to find the angle. So you have this as shown. Then you measure your angle starting from this until it reach F1. That is the angle of inclination, so you call it theta 1. For the next one, you measure it as shown until it touches theta 2. The next one you start, that's theta 3. The next one, theta 4. And the next one, theta 5. Let's observe it. Theta 1 is in between the range of acute angle. So theta 1 is going to be positive. Theta 2 is in between the range of obtuse angle. Theta 3 is also in between the range of obtuse angle. Whereby your theta 4 is now in the range of reflex angle. The same thing with theta 5. And from trigonometry, we have first quadrant, second quadrant, third quadrant, and fourth quadrant. So here, you don't need to use plus or minus for this approach,
because all these angles have their own respective sign while finding the sine, cosine, and their tangent. So which means that when you press your calculator for the sine, cosine, and tangent of any of these angles, a sign will accompany it, either positive, negative, positive or negative. So here you don't need to put plus, minus at any axis. Just press the sine, cosine, and tangent of any angle, then you can find the value. And the sign that accompany it, you use it in your calculation. That is the first method you can use to find the angle.
This is the second approach which I will recommend for you. It is very fast. You don't need to start using angle that is more than acute angle. Here, you are going to work within the first quadrant. So how do you work within the first quadrant without using angle that is greater than 90 degrees? So the same way, you now use your graphical knowledge, your graph knowledge. Now, what is the graph knowledge? If you are working towards the vertical position, anyone that is upward here, facing this direction will be plus. Anyone that is facing this direction will be minus, will be negative. Anyone that is facing this direction here, if you are working along horizontal axis now, anyone facing here, working along this direction will be what? Plus, positive. And anyone here will be negative. So fix that first. Don't forget, you pick the one you are working with, either vertical or horizontal. Now let's continue. The next thing is to now pick any angle, any axis that is close to your horizontal plane. For instance, if you want to find the angle for this F1, it is close to this plus sign. So when you measure the angle, you will surely get acute angle. So you pick that angle. If you are talking about F2, F2 is farther away from this plus sign. It is close to this minus sign, the negative. So you pick this angle over here. You measure this angle. This one is F. This one is theta 1. So you measure this angle. This is what I'm talking about. You choose this angle. You don't go ahead and choose this angle while you still call your F2 plus. If you do it that way, you will miss it. It's going to conflict with the sign. You have to use one approach. So if you measure this angle, it will be less than 90 degrees. But if you measure it like this, it will be greater than 90 degrees. Now for F3, how do you measure the angle? Now this one is what? Theta 2. Let's put it. We have theta 2. How do you measure this angle? Don't forget inclination between the horizontal and your force. How do we measure it? Very simple. It is close to this negative. So the angle between them. F4. How do we measure it? If you look at F4, if you want to measure it like this, you are now in obtuse region. So and don't forget, we want to use acute region. So it is close to this negative. So you pick it angle like this. So that is the angle 3, and this is the angle I'm talking about, F4 angle. And this is F4. And for your F5, you are not going to move along this direction again. It's close to this plus sign. So you pick the angle. And that is F5. That is the 2 approach. The first one, you just move anti-clockwise, starting from this horizontal plane and start measuring your angle, measuring your angle, measuring your angle. When you punch your calculator or using the knowledge of trigonometry, it's going to assign all these plus minus sign to your values. If you don't want to use it and you want to work within the range of acute, so you measure the angle between that force and the plane that is close to it, horizontal plane that is close to it. So that is how to do it, but you must now use sine. How do we use sine? Let me explain. To use sine, let's say you want to resolve this force F1 into vertical and horizontal components. For F1, if you are talking about vertical, is trying to push this object upward or pull it upward. So the vertical component will be plus automatically for F1. What about horizontal component? Horizontal component is pulling it along the right hand side. So that is why it's going to be plus, positive as well. Now let me choose another one. Let's say, for instance, you want to resolve this one, which is F4. To resolve it, if you look at F4 very well, you see that he is trying to pull or push this object downward, looking at the arrow now. Downward. So vertically, if you want to resolve it in vertical components, if it is downward, you have negative. Now for horizontal components, he is trying to pull or push it along this left hand side. So it is what? Negative.
And that is how to resolve force system that is concurrent. Now that we have understood how to resolve force system that is concurrent and make it a coplanar force system, it is now important for us to start solving questions. So I have two beautiful questions here. I'm going to solve it in the next video. Alright, if you haven't subscribed to this channel, kindly subscribe to this channel, click on the notification icon, share my video, comment in the comment section, and see you in the next video. Alright, bye for now.